Sasha A here. Has this ever happened to you? Is comp-sci keeping you from your loved ones or stopping you from doing the things you love? Do you suffer from assignment anxiety, quiz queasies, or presentation paranoia? Well then boy do I have the solution for you! It's called the Breakpoint Debugger, and you can get it within your IDE today! With the Breakpoint Debugger, you can crack down on problem methods, watch your code execute, line by line, or keep track of nasty variables. And all of this for 10 easy payments of 0, 0, 0, 0, 0, 0, 0, 0. Those are Bezos zeros! So call today and start debugging now. A message from the Government of Canada. Yo, yo, yo. Hopefully the audio works and everybody can hear me. If y'all can confirm, that would be awesome. Today, as usual, we've got a GitHub repository that we are cloning. That will be this link here in the chat. The procedure I'm sure you're all familiar with now, but in case you aren't, IntelliJ, VCS, get from version control, paste the link, click clone, you're done. Eclipse, you open Eclipse, you wait 10 years for it to open, then you go file, import, launch, come on. Eclipse takes its time to open because it's garbage. Give it a second, I'll show you guys how to clone the project into Eclipse. We'll be working mostly in IntelliJ today because that's where the debugger is a bit nicer to use, but it does work in Eclipse as well, it's just less pretty. Alright, so then you paste in your link to Eclipse, you click next, and then next a few more times because it has too many options, and then you're finished. Bam, it's there, you've got your stuff. Alright, today we're working in IntelliJ. So I'll put up the poll to ask you guys if you are cloned it yet. I'm logged in from another device, my polling session is inactive. Oh, come on. Can I make a poll from this device then? Nah, okay, well, goodbye myself from my phone. Don't need to monitor this anyways, so we'll start a poll. No. Okay, I can't start a poll. I'm not able to start a poll. So just let me know if you guys are not ready, and I will wait. And if you guys are ready to go and have everything cloned, that would be awesome. So just message the chat, turn on your mic, whatever you feel like. Not ready? All right. We'll wait up a little bit, wait for you to get ready by cloning this project. Today we will be editing this project in the bubble sort method right here. This one right here. We will be writing bubble sort. It'll be really easy. It's going to take the first few minutes of this class. We'll spend the rest of the class talking about debugging. The breakpoint debugger, very important stuff. How to deal with null pointer exceptions, how to deal with all the other kinds of exceptions. It's all about debugging today. It's the main focus. After looking at the survey from the previous assignment, I can see that very few people know how to use the breakpoint debugger. We're fixing that hard, going super hard on the debugging. So when everybody is ready, I'll get started with bubble sort, and I'll ask the chat to propose their algorithms. Then once you guys have proposed your algorithms, we will go through, we will run them, we will watch them run in the debugger, we will see how they behave, and then after all that is good, we will be good to go for more debugging. I'll show you guys maybe some assignments from last year and how those could be debugged, common issues people had, that kind of stuff. On Monday, we go triple down on the debugging. We go from actual examples from this assignment because it'll be handed in by then, so we can actually show you guys solution code, and it'll be great. So now that we're caught up on that, hopefully you guys have gotten ready to have the project cloned. And if you did, then we can get started. Let me know if you're not ready. If you are ready, we'll be good to proceed. I take your silence as an enthusiastic yes, and we will continue on this great endeavor. So I will ask that, do any of you know kind of how a sorting algorithm should work? What kind of behavior it should have? What should it do? Can anybody tell me what a sorting algorithm should do on the old mic? Yeah, exactly. Well, our goal in general is, when we're creating a sorting algorithm, is to come up with a way to compare the things we're sorting, and then to bring the ones that, well, in bubble sort, we want to bring the things that are small to the bottom, and to bring the things that are big to the top, or vice versa, however you want to think about it, big or small. Regardless, the point of a sorting algorithm is, yes, to compare different things. So like this should compare our data set and put it into a particular order. So now the question might be, how do we define something that is sorted? Like, how would you guys say that a sorted system would be defined? Do we have? Yeah, they're being ranked in a ascending order. Yeah, there is an order by which we have a comparable. Like, we're comparing our data set to each other. For example, if they're numbers, we're seeing which one is bigger. If they are, let's say, shapes, we're seeing which one is like has a larger area. Whatever, we can compare based on various things. The point of sorting is to say that the thing in the first part of the list is going to be the smallest thing, and the last part is going to be the biggest, and every consecutive thing will be bigger than the thing before it. And inspired by this property of sorted systems, bubble sort was created, and it's one of the worst sorting algorithms. We really don't like to use it. We basically never use it. It's just very easy to write, and that's why it's going to be my example for today. So bubble sort, there's a hint as to why it's a bad algorithm, and that is because it has a nested for loop. So can anybody maybe think of what the for loop for bubble sort would look like? Yeah, we could do a nested for loop like that. We can say for int I equals 0, I is less than dataset.length, I plus plus, and then we can do for int j is less than dataset.length, j plus plus, and we sort through this. So we can definitely do it like this. We can try to do it like this, though I don't know if that is necessarily the best way to do a bubble sort. Int j equals 0. I forgot to initialize it. Because we are iterating through the whole array where we want to be able to shrink our array as things gradually get more sorted. But for now, we can do it. Now I'm going to show you guys how I'm going to compare, because notice we're not actually sorting ints here. This might be different from what you're used to. We're sorting color objects. And the point of me sorting color objects is I'm trying to tell you guys that when you sort, you don't necessarily only need to sort numbers. You can sort any kind of object as long as there's something to compare it by. So today, we're going to be sorting by the RGB value of the color. That's just the brightness of the RG and B pixels of it. So we can say RJ, let's say. It's not R here, it's called dataset. My notes have a R. Oops. Dataset j dot get RGB. That is what we're going to be comparing it with. That's I'll send it to the chat as well. So this is how we get a number out of our color object. Or dataset there a number get RGB. So that's how we get the comparable thing for it. So what should we do? Let's say what conditions should we have in our for loop to help us sort? All right, well, when we're sorting, what do we need to do? Let's say if the condition is violated. Let's say the condition of this sorting algorithm is that we want to make sure that every single thing in the list is smaller than the thing after it, right? So we can say if it's not smaller, so if dataset j dot get RGB, and remember we're sorting smaller or bigger by get RGB, by the RGB value of the color, is less than dataset j plus 1. Now remember j plus 1 is just the one after it, dot get RGB. Now if it is that, we're going to say what do? Well, we want to switch their positions, right? We want to make it so that they are in fact in the correct order. So we can say data set, or we can't, to swap objects, we need to have a temp, right? Because if I just do data set j is equal to data set j plus 1, what's going to happen is we're going to have two of the same thing here. If I run this with a debugger, let's just say data set j is equal to, or j plus 1 is equal to data set j. Now this may seem like it makes sense, right? Like I'm swapping these two directly. But if we actually run this with the breakpoint debugger, so if I click on the side of a line in IntelliJ, or in Eclipse, if I double click on the side of a line, let's just show you in Eclipse as well how you would do this. So on any line in Java, in Eclipse, when you double click on the side of the line in this blue area, it's going to put a little dot. In IntelliJ, when you just click next to the line number over here, it's going to put a red dot. It's going to put what's called a breakpoint. So what a breakpoint does is it stops the code from running at that spot, and it shows you the values of every variable, and it lets you watch your code run step by step. So now if we run with the debugger, that's the bug icon. In Eclipse, it's this bug icon. And I know I'm covering it up with my face here. Give me a second. In IntelliJ, it's the bug icon right here. So we run like that. We should be able to see that when I click one of these buttons, it iterates through the data set. And now let's look. So data set j is a yellow value, and data set j plus 1 is white. When I say data set j equals data set j plus 1, well, now they're both white. So now how do I get back the yellow value? Does anybody have a clue as to how we could potentially not override our values and make these swap correctly? So the question is, we have these two values. We've got data set j and data set j plus 1. And we need to have some kind of way for which we can switch their positions. We can put j into j plus 1, and we put j plus 1 into j. Using a temp, says Ali. And that is a great intuition. So what we can do is we can say that color temp is equal to data set, let's say, j. Now we can say data set j is equal to j plus 1, and data set j plus 1 is equal to temp. Now we've created a good swapping method. So now we stop this, we rerun this with the breakpoint debugger, and then we watch it run. We can watch how this color temp is going to be a black color, j. Then this one is white, so we run it, and now you can see that dataset j plus 1, dataset j is black, temp is black. Now you can see that everything in the dataset is white. The whole array has no more black in it. It's just white, white, and this one is black. But since we saved black in the temp variable, we can then restore it to be the value of dataset j plus 1. Now that works. But I feel like, yeah, this might not be the best method. We got an array index out of bounds exception. So does anybody have any clue what the array index out of bounds exception could be caused by? Index 3 out of bounds for length 3. Like, what could be going on here? Exactly. The j only has to go to the second last element because we're accessing j plus 1 here. And if we want to be completely sure of that, let's prove this with the debugger. This is overkill. We're really using a really powerful tool for a job that's really simple, but I think it's best to learn how to use this debugger when you can understand yourself what the bug is like. So we're going to go back into this. We're going to see what's happening when it's an array index out of bounds exception. We're going through. Oh, okay. Are we at the big enough one yet? Now look at that right here. It shows us, before the exception is even thrown, where the index out of bounds exception is. It's showing us next to dataset j plus 1 right here, array index out of bounds exception. We know the dataset is a color, it's like of length 3, so the biggest index is 2. So when we try to access 2 plus 1, we get 3. And not even, it's showing you so much in the breakpoint debugger. I know it seems really simple, like the thing we're applying this to, but you can imagine how this could apply to much more complicated things, and you'll see that later in this tutorial. But right now you can see in the breakpoint debugger, j plus 1 evaluates to 3. The biggest index in dataset is 2. So that's why we get an array index out of bounds exception. So where does j plus 1 come from? Well, it comes from this, from j is less than dataset.length, which is 3. So now all we have to do to fix our code is do -1, and we rerun it. And we can see that this should fix our array index out of bounds exception. All right, swapping these things around. Now let's see if it's actually sorted. We got white, red, black. Let's try medium. I'm just going to run through our thing here. We're just comparing a bigger data set, so it's taking longer to loop through. And I just want to see if we're actually getting our sort to work. We're sorting by RGB value, so white is the biggest, red, green, blue. Hard to say. So instead, let's make this comparison a bit easier. Let's just say get red. We want to sort these in order of redness. How red is the color? We'll rerun this with just a regular run, no debugger. If we have breakpoints, it doesn't have to stop there. We can just run it like this. So now it's sorting by which color is the most red to the least red. And it actually looks like it's working. You can see here that the reddest color is on the left, and the least red color, the blue, is on the right. If you see how that's running. But I'm not sure that this bubble sort is really, well, I don't know if it's really ideal at this point. I'm not sure. The reason I'm not sure is that I'm not sure it's doing the best of the job because I can't really tell if which color is reddest by eye. I can only tell it, like I want something objective to prove to me that it works properly. So to prove to me that it works properly, what I'm going to do, you know, I could do this. I could say here at the end of bubble sort for, let's say, color C in, this is an enhanced for loop. It's a for loop where I don't have to have an index. In dataset, system.out.println c.getRGB, or whatever I'm comparing. Right now I'm comparing by getRed, right? So I run this, I do the hard, it goes from biggest to smallest. Okay, fair enough, but there is actually a better way to do this where I don't have to interfere with my code. So if I go into my breakpoints and I click the bug icon, remember it takes forever, it's kind of annoying right now. I have to click the next frame item a lot. And what next frame does, of course, is it moves to the next line. I just click this little, you can see where my mouse is. I'm clicking this little button, it goes to the next line of code. I go through this, it's taking forever. We don't care. We just want to know the start and the end of this method. So we can go to where this method was called, which is here. Dataset is equal to input 0, bubble sort dataset, done. Go into here. Run it with a debugger, and now it's going to pause over here. If I do, let's say hard, it's going to say that our data set is equal to the first part of index. It's completely out of order right now. We've got the yellow one first, and here red is 255, 255, 0, 0, 128, 255. We go through. We hit bubble sort. We go after bubble sort. Oh, it doesn't pause after. Let's just put a blank line here. Yeah. Now we can see it after the method. It's a little trick for the debugger. Hard, we can see go through, go through, go through. Oh, no, it doesn't want to stop there. Oops, give me a sec. I'll just do a... Just want to see a pause after this method. We can also put a breakpoint on the method, but for the sake of quickness today, this is what we'll be doing. I'll go through this. I'm going to write bubble sort for this. I'm going to run it with the debugger. Hard. We just want to see the result of the method. Okay, so now dataset has been sorted. We look through dataset, and RGB doesn't look very good. Bubble sort dataset has already run. We've got a problem. It looks like it's not actually sorting correctly. Go through. Yeah, we don't like that. We don't like that at all. Let's inspect bubble sort once again. Somebody asked if I could show this in Eclipse. I could show it in Eclipse, but it's just a lot less easy to demonstrate in Eclipse because the interface just kind of sucks. It gives you like a Excel-style spreadsheet of your variables. It's not worth looking at, really. I'll show it in IntelliJ. I can briefly cover how you could do this in Eclipse, but I really recommend that you do. Why do I print an empty line? I wanted it to stop afterwards to show that, like, well, normally in this I would have like other code here where I could have it stop on a line afterwards, and I could inspect the return of this method. Since this was the last method, I didn't have any line to put here. Like, no code was running here. And I couldn't see what happens after this method. I would have to put something around where this constructor was called otherwise. So I put this line that basically does nothing in order to be able to pause right after this executed. It's a bad technique. It's not how you should do it. You should be putting a breakpoint somewhere which calls a array drawer, or you should be putting a watch on dataset, which is basically something that updates every time the dataset changes, or you should be putting breakpoints in the method you're calling. But just for the sake of a demonstration, I put this here so I could show you guys that if you had more code in this, like code after this, that you could pause on lines afterwards, if that makes sense. Like you can pause on the line after this to see what the value was. All right, so going through dataset, let's see what's happening to it. We're modifying. Let's just see. Let's take a peek at it right now. So temp is the sorted array. And, or no, temp is not the sorted array. Temp is the sorted variable. I was doing deletion earlier today, so that's why I thought that. But yeah, dataset is gradually being bubbled up to the top. You can see we're sorting by red value, so the two values at the top right now have 255 in their thing, and the one with 128 should gradually be climbing. Is it? No, the one with 255 is gradually climbing. Oh, okay, gradually. We can actually watch it run here at the bottom. The 255 and the 128 should get compared and swapped. Okay, cool. So it looks like it is actually sorting. So what's going on? Okay, now we're unnecessarily looping a lot because this is not yet optimized properly. You can make a better version of bubble sort, which stops when everything is equal. Like you can have a Boolean swapped, and you can do that. I can leave that as an exercise for you guys because today I want to focus on breakpoint debugger. So I won't go into too much detail on the sorting anymore. But essentially, we've gone through this and we've seen that this algorithm does what we expect it to do. So maybe there was an issue with how I was breakpointing it up here. And the print line works, but we can also do this. We can stop and rerun. And we can do the best trick, in my opinion, of the breakpoint debugger, which is, well, we have to put breakpoints first, which is to actually view a variable in real time as you're running. So we'll go into here, we'll run it with breakpoints, do hard, go through the whole thing up until I is at dataset.length. We're going high up. I is 1. We're going. It's going to be really slow because bubble sort is ridiculously inefficient. Some of the inefficiency of bubble sort comes in because it loops through this content twice. So you notice how this goes. So if m is the number of things in dataset, this takes m time, and then so does this. And then because these both take m time, this nested for loop takes n squared time. That's a bit of runtime efficiency stuff. That's why this algorithm is so bad. So this takes n squared time. We go through, we wait until the top loop gets to oop, I missed it there. We can not put breakpoints and everything. We'll just put breakpoints on the outer loop, and we'll put a watch on graph or on dataset. Oop, oop. Hard and go. 3, 4, 5. All right, so now we look at dataset, hover over it, and we can actually see what's in it and what's changing. And we can see that it has indeed not updated. So what it looks to be doing is it looks to actually be well, it hasn't updated. It looks to actually be correctly sorting it, and it looks to actually be updating the graphics application as well, but it looks to not be showing that until it's completely done executing. So it is sorted, in fact, by its redness, 255, 255, 255, 128, 0, 0, and it is in fact sorting. And to confirm that, we could look, in fact, in the into the thing here. Again, if we do by breakpoint, we go into here, we go like this. And yeah, when it's hard to tell, you can remove all the ambiguity about how it is to run just by going like that, hovering over dataset, watching it, seeing we want the 255s to be at the top. We go through. Now we hover over it again. We can see more of the 255s are at the top. This one is gradually bubbling up. One more run. It's getting closer to being sorted. This 255s are moving upwards. One more run. Oh, it looks like it's not changing for some reason. One more run. Should be updating with the 255s going upwards. Data set. Oh yeah, it is. It's just very slow. I underestimated how slow bubble sort was. So here we can see it continues to update. 255 continue to bubble up. Go one more time. 255 continue to bubble up. It's just like a few more goes until it's completely ready. There you go. Not quite. Bubbling up. And then one more time. And we just watch it change over time. Still takes forever to bubble up. Now it looks like it's finally sorted, and we can view the value of that. So how does this help us with exceptions? Well, let's say that we've got this bubble sort down. We've seen that it in fact sorts things. Let's go into previous assignment from last semester, and you guys are going to help me debug. This is going to be the big debugging session of today. Half of this tutorial, just debugging. That starts right now. All right, so we go into our assignment 1 last semester. Now, we can do a bit of a game with this. You guys tell me a line number you want me to screw up. So we're going to go into any of these classes. Just give me like a line number in the chat. We're going to mess it up. We're going to see how we can fix that. That can be for, let's say, between line 12 and 20, which one do you want me to screw up? Or I guess between 12 and 19. Pick a number between 12 and 19. We'll screw it up. 13. Perfect. We don't like 13. We're just going to remove line 13. I'm not even going to read what it said. I'm just going to I saw that it screwed up there. I'm just going to remove line 13 completely. And we're going to see what the tester does now. This is a mini tester, the exact same as we had this semester. It's all pretty much the same stuff. It's just a comparable assignment. Well, now it looks like we removed the constructor from flight reservation. So you guys definitely picked a good one to remove. But this one is not exactly good for showing the breakpoint debugger off because, well, removing the constructor, it can't compile. So I'll remove the setter inside the constructor instead, if that's an acceptable a version of that, because we do want it to be able to compile. We just want it to have exceptions. So we run this mini tester, and now we're getting null pointer exceptions. Now you see, I just indiscriminately deleted a line from this code. I did not think about which line. My grade now sucks. It's got 66. Like, this is terrible. Gonna drop out. Awful. Switch to business. This is terrible. So how do we deal with this? Well, we look at which lines threw the exception. Line 28, 26. Anybody have any clue what we could start doing to figure out where this was if we pretend we don't know what line we destroyed? Now remember, we're not familiar with this code. We don't know what this code does. We have absolutely no clue. We just want to find the source of the exception. So how would you guys go about finding the source of the exception in this situation? Well, look at line 28. Yeah, exactly. So return this to reservation.name. It looks like it's a big series of ands. Complicated, confusing. This is not in tutorial 5. I'm actually just using an assignment from last year. I'm debugging this assignment from last year with you guys in real time to show you guys how the debugger works. But I won't be sharing this assignment with you guys because I don't know if I'm allowed to share previous assignments publicly. But I'm allowed to show them, I guess. So, well, I think I'm allowed to show them, hopefully. Otherwise, oh no. So go through this, put some breakpoints on here. This is what I'm doing. I want to know what's going on around line number 29. I go here, I see what's happening. So it looks to me like we're failing dot equals here. So we go into here. Oh, I've got breakpoints all over the place. That's a problem. Yeah, I had breakpoints on this from last time, so let's just... I was doing like this similar thing in FAQ office hours. That's why there's breakpoints all over it. I'm just going to delete those. Excuse that. And I screwed up a different line there, so it doesn't give us any spoilers, don't worry. I probably should have removed these beforehand. We did a fair bit of debugging there. Bear with me for a second. Oh my, I'm really going crazy with this, huh? Okay. Okay. Let's run this with the debugger again. Line 28 is where we had the problems. Breakpoints all over this damn thing. Let's see what it's doing. All right, so if the get class, oh, it looks like it's an interesting class comparison. This is like instance of, but another alternative, I guess. It also works. It's just not the most elegant solution, but we're not here to roast this code. We're here to figure out what's giving us exceptions. So the test is that. Now we're returning this, going through the lines, and we fail. Okay, that's not informative at all, is it? So is this useless? Well, no, we just have to go down our stack trace. So we can see here Line 376 is causing this. So let's see what's happening around this situation. What's happening before and after? That's kind of the whole theme of this. So I'm putting breakpoints just kind of generally around it, as you feel, seeing what's happening. So here, we're seeing that we create all these rooms, okay? And what are we noticing here? So we look into this room, we look at the details. Okay, it looks fine. Hotel H1. Everything looks okay here. It doesn't look terrible. Yeah, cool. Now we just keep going forward. That returns true. Okay, and we're getting exceptions. No worries. Let's go through it more. Line 29. That's just changing our score. Not interesting. Not too many hints. Let's try this part of the stack trace. Look through here. And we're getting another call to dot equals. What are we noticing in these things? In this one, we call dot equals. In this one, we call dot equals. In this one, we call dot equals. And I'm going to guess this one probably also calls dot equals. Well, it does. And these two are on the same line. They're just being compared from a different part of this. So, because we have so many calls to dot equals, let's actually see what's up with this dot equals method. We can go to declaration or usages, Control B, or just find it somewhere. We can see that there's this dot equals method. It looks, oh, it's the dot equals method in string. So what's going on with this? It's a null pointer exception. So there's a string that's null. So what string could that be? Well, it's input reserve dot reservation name. Okay, let's see what's happening with that. If I run breakpoints around that, we already know that this is all doing fine. We just remove these breakpoints. We can remove these in real time. We know these breakpoints are probably not doing anything useful for us. We can go into here, we go next. Okay. Reservation name, what does this evaluate to? Hover over it, hover over this. Name is null. Okay, that's interesting. Why is name null? Well, we found why we're getting a null pointer exception here. It's because name is null. We keep going forward with it, and here, we can also notice here that this here also has, by this I mean like this thing, also has a name of null. Go through it again, null pointer exception, null pointer exception. This has a name of John, that works, and input reserve has a name of null. So we're finding a trend here. We're finding that the name of input reserve is always null. So let's go and let's examine what happens to input reserve. Go to declaration or usages, or no, go to, yeah, input reserve. That is a reservation, no? Flight reservation, okay. So we go into flight reservation. We see, okay, a flight reservation has what properties? It has a departure and arrival, but it extends reservation. So let's go into reservation, and we've got a private string name. So does name ever change? Well, we can see that name variable is gray and IntelliJ, but let's pretend it's not. We can go to implementations, and it says no implementations found. That means, see when I click in IntelliJ, go to implementations, what that does for a variable that is actually used somewhere, let's say for example departure. Well, that's not actually good either. Go to, well actually here, declarations or usages, I'm being silly. We can see what changes it. So we can see here that it's being like set here and gotten here. I got my my wording mixed up there. What I meant to say was declaration and usages. So if we go into reservation here, we right click, we say go to declaration or usages. It says its only usage is in getting the reservation name. And that's a bit of a strange thing. It's only got, it's never set. Now if we look at something that's normal, we go to this declaration or usages. We can see here it's get, here it's set, all over the place. It's got all these different usages. And that is suspicious to us. So from that we can tell, since it's never set, where should it be set? Well, here we've got a public reservation constructor, which takes an input, a string, an input name, and it sets it. But here it doesn't set it. So fix that line should be pretty obvious. Though I know that seems cherry-picked because like we kind of knew what line it was. So just to confirm that that worked, breakpoints are still here, but now it actually evaluates everything instead of crashing on that test. Goes through, lots of stopping here, lots of different stuff, and eventually we can see it perfectly worked. Alright, so now I'm going to go into a different class that's less obvious, and we can try this on a harder example. So can anybody come up with a, let's say flight reservation, this one is really big. Come up with a line number and I'll just nuke that line unless it's a method header, in which case I'll just nuke some random line in the method. Actually, yeah, let's pick a method first. We've got these methods and fields. Which one do we want to nuke from? I'll give you guys a list of options. Which one of those do we want to nuke from? Which one? Oh, airports test. Sure, yeah, let's nuke from airports test. So in airports test, we've got lines between 35 and 50. So between 35 and 50, which lines do you want to remove? (42). Cool, that breaks this else statement. Let me just fix that notation so that it actually compiles. Let's see, what did I break? I created an open bracket. This closed bracket shouldn't be here. And this return statement. So that broke a lot because it was an if statement, but it's okay. We can just break the if condition. Let's just change this to an equals. All right. And I'll just put like a little note here that this is the thing we screwed up, just so I remember in case we completely screw up. Let's run mini tester. Let's see what happens. 82 out of 100. So we screwed up something. Don't know what we screwed up. No clue. Just remove the thing, made it compile. Don't know what exactly happened. But basket.remove doesn't shift the products down. Okay. Let's figure out what exactly causes this error. This applies to all your guys' assignments because you also have mini testers like this. When you see an error in mini tester and it throws no exceptions, you control F, find the thing it prints, and look what happens. So here, we've got this big try, and this is what's causing this issue. Let's just put breakpoints all over this thing and see what mini tester is doing to cause this problem. See what it is. Ooh. Okay. B1.remove. Where is this? False. Remove doesn't shift the products down. Interesting. Okay, so let's look at the value of basket, see what it is, see what it should be. This equals method still has breakpoints from before. Let's just nuke those. Okay. So res equals b1.remove r2. Boolean res. So let's see. R2 is a reservation. B1 is a basket. B1 has a reservations array of reservations 864, 865, and 866. We wanted to remove reservation 865. Makes sense to everyone? That's the goal. We want this to be removed from here. Let's see what happens. Res is false, and we've got some exceptions, I guess. Yeah, no. It didn't throw an exception, but it did cause a problem. So let's see the value of res now. Or not the value of res. Let's see value of B1. We hover over B1. It didn't remove the item. It simply just didn't. It wasn't removed. Okay, and it should have removed, right? Because it's in there. So let's go examine the remove method. Go to declarations or usages. Here is remove. Okay, let's go through here. I'm going to put breakpoints all over remove. And see exactly what it does. Okay, b1.remove. Reservations is not null. Cool. The one to remove is not valid. You go through. Find the one to remove. Return false. Okay, so it's saying that the dot equals is seemingly never returning true. Let's see what's happening here really. We'll rerun with the debugger and we'll take it slow this time and we'll see slowly what's going on. So remove is starting with it's not null. Okay, so let's see what's in reservations array. We've got 0, 1, 2, 3, 859, 860, 861. We want to remove 860. We go in here. All right, we want to remove reservation 860. Which one to nuke is I, but it's not equals. Which one is not equals? So reservations array at 1 is 860. Input is 860. These two should be equals, right? They're the exact same thing. That is the memory address, yeah. When it says at 860, that means it's the exact same flight reservation. So if I look over here and I have reservations array I and input, these two should be equal. And you can see that they have the same memory address, which means they have the same airport, which means they have the same arrival. All of their properties are the same because they're the same thing. In memory, it's pointing to the same thing. If you do like an equals equals, it will return true. They're that the same. But for some reason, equals is returning false. So we can be pretty sure that despite that we can see with our eyes they're the same. But we can see that equals doesn't think they're the same. So let's see why. Go to... Oh, because it's just doing a comparison to the object equals. We didn't override equals in this one. That's an interesting problem. But that's strange because it does actually equal it. So that is the weirdest thing ever. This should actually have an equals method. No, I'm just going to double check that, that this does have an equals. Go to declaration or usages. It's a basket. No, we want... where are we debugging from again right now? We're debugging from basket as well. Reservations array is an array of reservation, no? Yeah, it is. So if we go into reservation, oh, it has no equals. That's why. It's just comparing memory addresses. But that's no problem because it has the same memory address. That's fine. But this is returning false. Okay, or is it? Okay, so it's turning out that this one is returning false despite the fact that it has a memory address that is valid. So now we can go through and we can debug further by seeing what else it's doing. So which one to nuke is -1? It's not updating. Reservations array is not null. We're going through. And right away, we've got a major problem. So what else could be causing this problem? Well, this is not the only method we fail, because add also doesn't work. So this one feels like a dead end, but it's not the end of the world, because we have more to check. And I think maybe a combination of these problems will lead us down the rabbit hole to find out what's going wrong. Because it could also be that the object is not being constructed properly. Something like that. We don't know this yet. So we can, or it could be that some parent object is not being constructed. So let's put breakpoints all over this other one that's failing, and also see what's wrong here. I'm going to run this with the debugger. Okay, so we've created all these objects. We've added this one to B1. So B1 is a basket. Let's see its value. It's got nothing inside of it. We're going to add R1. And now it has R1 inside, which is a flight reservation. It's got an arrival, it's got a departure, everything. Perfect. We have got a superior grade, did we? My reservation's 0. Reservation array of 1 has this. Name my reservation. Arrival, departure, okay. Now R1, it's at 862. This one is at 860. So they are not the same memory address, but they do have the same properties. No, 8, 7, we can check that in here. So B1, or my reservation 0 is 859. R1 is 860. Departure is, oh no, these are the same. These are exactly the same. They're both at 860. So they should be equal, dot equalsing each other. And are they? I don't want object. Let's see. We'll go to the next line. By the next line, I'm going to go into here. We'll see this. We breakpoint into dot equals. Put breakpoints all over this thing. Hit debug again. All right, so it looks like this is being compared to that, and it's returning that the reservation name is equal to the reservation name of test, an airport's test. Okay, so which one of these is true? Which one of these is false? So does this reservation name equal to get reservation name test? So this, let's see. Let's hover over this. Let's see what the value of the name is. Name is my reservation, and get reservation name on test. Let's see the name of test. Test has a name of my reservation, so this must return true. We can just see that by inspection. Now let's see, airport's test. What the hell is airport's test? Go to declaration or usages. So airport's test is this big old method. You can see it's being debugged the stupid way before by me. All these bloody print lines. So now we go into here. We see that when it's comparing them, it's checking that the airport's length is the same. Then it's checking, it's iterating through the airports. Make sure, now it's checking that if the cost is the same as the other cost, return false. That seems pretty stupid to me because it's saying that if they have the same cost, they're not equal. So it looks to me like this was just like a flipped thing. So we could probably say return true. Because again, we're comparing to see if their costs are equal and we were returning false. So if input 1 get cost is input 2 get cost, return false. So we'll put a semicolon return true. Return true. And let's rerun it and see if that fixed our problem. Looks like it did. So what happened was this problem was actually in this equals method. It was in this equals method, but it wasn't actually in this equals method. It was in airports test. So, and this problem was also in some other method. Like the stack trace was not the whole story, and no exceptions were thrown. So we had no easy way of finding out where our problem was. But by working through the thing and figuring out exactly where the logic went off and going through the debugger, we could kind of break it down to get to where the problem started. Does that make sense to everyone? Do you guys kind of feel how this would apply to assignments outside of this one? Like, you could have a mistake somewhere. It's not necessarily obvious where it could be. But by putting breakpoints all over the place and just watching it run and comparing it to your logic, you can figure out where something went wrong. Another quick tidbit is that this is, although this is a very good technique to use, it's not always your savior. So there are still times when printing is appropriate. Like there are situations. You can basically use breakpoints anytime you print, but sometimes it's just more convenient to print. Just make sure that keep it tame. And once you get good at breakpoint debugging, really no bugs could phase you because you can clearly see what's going on no matter what you write. Now, as a little bonus for today's thing, I'll let you guys ask any questions you want about somewhat assignment-related questions. I can't help you with anything directly on the assignment, like super directly, like code sharing. But if you have conceptual questions, I'm happy to answer them. And if not, I will be happy to show you a drag race between different sorting algorithms. So let me know if you guys have any questions about assignment-related topics, but not actually things on the assignment. That one will have to be a surprise. But besides that, oh. Oh, I thought you meant by the topic like the B thing. No, the topic for assignment 2 is not going to be anything runtime efficiency yet. I don't think so. It's probably going to be under linked lists, that kind of stuff. It's most likely going to be linked list or array list. It's going to be something you've seen right after you saw, like, you know, the content you saw in this assignment is going to be the content directly after. So it's probably going to be stuff like linked lists. If I pass the mini testers, do I at least get a specific grade? Yeah, you can expect at least around like 40% on a mini tester, and then you can expect more if you did the GUI and everything. We don't know the exact, or I don't know the exact percentage that you're going to get from the mini tester, and it varies by assignment, but we can be pretty sure that you're going to at least get like half the marks from the mini tester, and then you're going to get more if the GUI works, and then you're going to get more if your own debuggers work. Oh, and a thing about making your own debuggers is when we say you want to test edge cases, for example, with a data structure, you want to test removing something at the very start of the data structure, removing something at the very end of the data structure, adding something to the middle of the data structure, adding something to the start of the data structure, this kind of stuff. It's much easier to explain when you have like a data structure in your mind or something like that. With something like a B assignment, that would apply to something like the swarm maybe, where you'd be testing that kind of thing. But if you're making, like, say, a linked list, you want to test removing the start of the linked list, removing the end of the linked list, all these different cases. These are weird cases that you guys want to test, and I'm sure you guys can come up with 100 more of them. That would be a great thing to do. Now, besides that, we've got, well, any more questions? No, if you need to worry about time efficiency, we will tell you. We will tell you in advance, and we will tell you in great detail whether or not you need to do time efficiency. It'll be made super clear. In last semester, we only did time efficiency on the last assignment. This semester, we're probably going to be doing time efficiency for like maybe the last couple assignments, if not just the last. Yeah, it's nothing we've learned yet is time efficient. Like bubble sort is super slow, terrible. Linked lists are pretty bad too. Time efficiency is not something we've even touched on yet, really. Like we just introduced the concept, but efficient stuff hasn't really been touched yet. We're doing the least efficient stuff possible right now. So we're not going to be testing for time efficiency yet. But don't worry, we'll get there. And now, as like our last little tidbit this tutorial, to make it totally equivalent to last time, I'll show you guys what we mean by runtime efficiency. So when we talk about runtime efficiency, we're talking about how much stuff we put into a given algorithm versus how long it takes to run. So for example, if you want to put in 10,000 things versus 100,000 things, something that is O of n will have a linear amount of time it takes. The one that is O of n squared, like bubble sort, will take, let's say, it would have taken 5 minutes to sort 10,000 things. It would take an hour to sort 20,000 things if it's of n squared. If it's O of n, it'll just take 5 minutes to sort 10,000 things, 10 minutes to sort 20,000 things. Makes sense. It's like the graph. Imagine it's, how can I say this? Imagine it's like the actual curve of the amount of stuff in your array versus how long it takes to sort, for example. But it applies to anything. So amount of things you have to do, how big it is, versus how long it takes. Now to show you guys an example, I've put this up on the screen. This is a grapher which graphs different algorithms. Here I'm just going to show you guys this slow sort, which is similar to bubble sort, and merge sort. And you can see the difference. See, they start off about the same, but slow sort, which is like bubble sort, just quickly gets slower. And it's not exactly a curve up, because remember, O of n, O of m, all that means is that's kind of what you expect from the runtime. It's like an upper lower bound kind of deal. But it doesn't mean it's going to guarantee you to have that runtime at all times. It just means that you can expect it to kind of follow that curve. And you can see here that the array list, which is supposed to be like O of n log n, I believe, then that is supposed to be done much faster. It's growing so much slower than O of n squared that, well, you can just see it at the bottom there as a tiny, tiny line that's growing so much slower that it basically looks like it's on the floor. Whereas the O of n squared one is growing super fast, and it's like an exponential curve up. And that is the difference between different runtime efficiencies. And if we look at our bubble sort, we can see why that is, because, yeah, where's bubble sort? Oh, it's not even open here. It's going to be open somewhere else. Let me just get that for us. Tutorial 5 Monday, new window. We wrote bubble sort really early on. I barely remember it. But here, see, we're looping through the whole data set once. We're looping through the whole data set twice. That's where n squared comes from. This takes n time because it has to reach n items. This takes another n time because for every n items, it has to reach n items again, n squared. That's why this graph here for bubble sort looks like it's going up like a function of x squared, whereas the one that's going much faster is just basically staying on the floor. And that's where n squared comes from. I could show you merge sort, but it's recursive and it looks a bit harder, so it's going to be not as easy for you guys to visualize as something like bubble sort. I like bubble sort to show an example of this because bubble sort literally has 2 nested for loops. And in computer science, if you want to identify a slow algorithm, the fastest way to identify a slow algorithm is for loops. If you've got a single for loop, probably going to be O of n. If you've got a nested for loop, it's probably going to be O of n squared. Got 3 nested for loops, O of n cubed. Make sense? Hopefully. We've got every nested for loop, consider that another power of n added to your runtime. If you wanted to make O of n to the 4, you would just do 4 nested for loops. That's not the only way. You can have nested for loops that are faster if they have a break condition before you get through the whole data set, but that's the general idea of it. And here is the exponential looking curve of bubble sort if you guys want to see it. All right, guys. Thanks for showing up. It's been a great tutorial. Hopefully you guys did awesome on the assignment, and you'll destroy the next one too. I'll make sure to cover more debugging stuff and practical things for the assignments in upcoming tutorials, and we'll probably be doing dedicated little things on common problems from the assignment as well. So good luck, fellas. Enjoy.